Hello, Tom. How you doing?
Doing well. How are you?
I'm trying to keep it between the ditches. Hope everybody's
Yeah,
doing
pretty.
well. Hey, we'll give it another minute or so here, just with people trying to get on. We have 55 people enrolled in this. We have 14 people signed up, but we won't punish people for being on time either. We don't want to do that. All right. Tom, you have control of the slides right now.
Would you like me to hand that over to you?
If you want to, that'd be fine.
Okay.
Doesn't matter. I mean, it really doesn't. You can be it. That's fine. It's just we're going to run down where it starts with Arduino code or hooking up the LED. I thought I heard you say.
Yeah, we do a little bit with the 123D circuit, and then
All right.
move on to the Arduino code. Yeah.
Let me go to 123.
Let's go ahead.
Have you done a check to see if how many people have the Arduinos with them?
I have not.
Folks, if you'd be so kind, please raise your hand if you have an Arduino with you. That'll give us a sense of. Okay, we have right now about 3 of 16 that actually have an Arduino. I would really suggest if you can get one from school, talk to your teacher about getting one, record this webinar, and then do it at school. And then also pay attention to 123D circuit. Mr. Toy there, Tom, will probably show us a little bit of this and go into that, and then I will build it as well on a 123D circuit and show you as well. Okay. All right. You want to start, Tom? Go for it. I think it's
Sure.
7:05.
Okay. So last we left off, we had gone over the hardware and the electronics, or at least some of them, that were in the SparkFun kits. So we went over the ins and outs of the Arduino. We spent some time going over breadboards and LEDs and all that kind of stuff. Spent a little bit of time talking about schematics. So it was pretty simple. It was more or less an introduction. We also mentioned 123D circuit, which is a simulator, and it's actually very useful. It's a very comprehensive simulator for a lot of the purposes of what we're doing. So it will allow us to at least look over the circuits, and at least on my end, I can show you guys on 123D circuit how something's supposed to be built, which might help make things a lot easier for you guys. But it's very useful for prototyping and for designing a circuit before you actually build it physically. So with that in mind, actually, if we could all head over to 123D circuits, it's at 123d.circuits.io. Alternatively, you can enter it into Google. Let me just go ahead and paste it to the chat box here. You can actually get started looking at that and getting familiar with it for later use. Now, I guess just a real quick show of hands. Who here has already used 123D circuit or has a a login for 123D circuits? Okay, so a few people. Not everybody, but a few people. Well, then it should be a lot easier for you guys. We'll just give everybody a minute to get signed up on 123D circuits and get logged in. I'm already signed into my account because I've done this last year. 2015, that's not right. But hopefully we should be able to prototype the circuit today, get a little bit familiar with 123D circuits, and then we'll move on to the programming aspect of Arduino.
All right, while we wait for folks there, Raise your hands once you're ready to go with it, folks, so that way we know and we can move on. It is a little bit slow getting. Oh, probably missing something.
And of course, as always, if you have any questions about anything, feel free to throw them into the question box, and
We also
we'll
have,
answer them.
yep, and we'll try to answer them. And we also have a handout. If you weren't here last week, if you go under handouts, you can download this as a PDF. Feel free to share it.
Thank you. Actually, that's a good reminder. For those of you who are signing up, make sure it's in Chrome. That's really the only one that we can sort of guarantee with any degree of accuracy that it's going to be working, or that it will work. Firefox, Safari, Internet Explorer, all of those other ones, Opera, it's going to be a little dodgier to ensure that they'd be working, or that 123D circuits would work with that software.
All right. Would you like? You're going to lead this part, Tom? You want me to do the setup here, and then you take over the programming? What would you like?
I can do the programming. That works for me.
All right. Why don't I do the 1, 2, 3 circuits here, and the people will give me the screen. I will go through this. I'll start off first. We're just going to start off and use the Arduino like a battery, and then so everybody can see how you would hook it up, and then you can take over and show them. Then we'll show it again how you would set it up using the 123D circuit, and then Tom will take it over and teach programming. Take it out with that. Okay, folks. Real quick again, how many people have done any kind of text-based programming? I'm going to put everybody's hands down. If you've done any text-based programming, that will be helpful. It's not absolutely necessary, but it certainly is going to give you a hand. I know Sarah has, but okay. All right. Tom, if you'll hand it over to me, we'll get rolling on this thing. All right. We got some of those people done that. And then one last time. Sorry, folks. Raise your hands again. I'm sorry I've asked you to put your hands up and down. But if you would, raise your hands and let us know if you've got 123D circuit. Tom will give me the screen here in a second, and then I can show you where I'm looking at on this and where to go.
Sorry about that. I'm making you presenter right now.
Gosh. All right. Let me know if you can see my screen here. I'll get rid of that. All right. Okay. So most people have 123D circuit working now. That's awesome. We're ready to roll. I know that word gets overused. Okay, when you bring it up, first thing you're probably going to see is a breadboard. All right? Here's an Uno. Here's a breadboard. And then it comes up with this. Let me back on it. It's kind of annoying. If you click a line, it immediately thinks you want to put a wire on it. How did I get that Arduino? Well, I went down here under components, and I selected Arduino Uno R3. And it shows that. That is the same thing as your breadboard with your breadboard component. All right? So when we do these things, Arduino Uno is the same thing as that Spark Fun board you have. And there are a lot of different clones in that. So I dragged it up there. I'll delete this one, but so you can see it. Right here is Arduino Uno. If I pull it up there, it would come up right like that. You'd pull it up on your screen. And then it would be named number 1. You can name it, if you have multiple Arduinos, you can give them different names. One's fine for what we're doing here. And see, you got the second one. I got the second one. I dragged up. I didn't just delete it because I saw no point in having that. You don't need the second Arduino. Now, what do I want to do if I want to move any of this equipment? If I click on it, notice the name changes. I click here, the name changes. turn the R right around like this. So I move that breadboard around. And again, this allows us to simulate. This allows you to practice and troubleshoot without having the equipment there. And that will certainly get you ready for the contest. All right, now we're going to hit Arduino. I'm hitting R's and moving it. I'm going to move it right over like on this side, right here to begin with. I'm moving this over with my mouse. Again, I can switch those with the R keys. Go ahead. You can also use the keys up here to kind of play with things, but there we are. We're set up right there. So, putting everybody's hands down. Got a question? Ask it right now. Raise your hand once you have your Arduino, just like this. And let me see if we got any questions. I'm wondering, yes, good. I missed all last week. I signed up. All right. Yeah, well, just pay attention to what we're doing now, and this will get you up to speed. And if you go back, there was recordings from last year that will absolutely very similar to this year, and we'll put up the new recordings as the weeks go on. Okay? So don't worry. I think we probably pretty much have a lot of students here. We're excited to be working with you. Okay, we've got a lot of hands raised, so we're going to get going on this. All right? So I look at my Arduino. I'm going to use my mouse and blow it up a little bit. And what I'm going to do is I'm going to take 3.3 volts, that line there, and I'm going to run it over this row right here. So let's go to here, click, and then click again. Now, any color wire will work, but it's really helpful if you give them a specific color that'll help you troubleshoot. So we're going to use red is generally considered hot. So that's 3.3 volts, just like on a little battery. And then, like a battery, you need a ground. Remember, electricity goes from high potential to low potential. You see that often in science. All right, so here you go from here. And again, if I click on that, I can change it to black. And as we saw in the last webinar, there's your ground, there's your hot. We're putting them in this rail. Goes, and look, when I put my little pointer, it goes all the way up and down the rails. So this is a great way to remind yourself on a breadboard how it's hooked up. So anything along that green rail right now, that's the real deal. It'll connect. Anything along this rail connects. These rails connect. They don't connect over here, just there and there. So there's red. Notice now that's the ground right there. Okay? All right. Put my hands down. Raise your hand if you have the hot and the ground on. If you have the red or good. All right, great. Excellent. All right. Now, let me, Randy and everybody else, raise your hands. Say if you don't have a computer so you can't do it, go ahead and raise your hand so we don't wait for some people that will never be able to do it. Okay? Leave your hands up so we know. So like David and Juan, let me know if you're going to be able to do it. Raise your hand. I don't know if to wait. Megan, let us know. Randy and Wakir Williams, let us know. All right. All right, good. Now, we have power here. So, that's going all the way up this thing. So, the next thing I want to do is I'm going to go ahead and add another component. And I'm going to go here, probably to the top row. And I'm going to look until I find the most favorite thing we use is the blinking light. So, here it is. Now, if I put it here, it's in wrong because these rails are all connected. And this doesn't work that way. You want to go across rails when you connect. So I'm clicked on that LED. I'm hitting the letter R. Now I'm crossed. There's the long leg is that slight curve, the anode. You can look, there's the cathode. Okay? Now, we also would be probably not a bad idea to put a resistor on there. So there's my LED, and I can call it first if I want to. My first red, or I could call it red. Yeah, it's color red, so first, I'll just go first, LED. So if I had several LEDs, that might be something I do. I'm going to make it red because that's always a favorite color. Then we got a component, and then here's a resistor. I'll put the resistor right on the same leg as the long leg of this LED. Now, there's the value. It says 1K ohm. In a perfect world, I would all ask you right now what it is. That means, but we don't have a lot of time, so we're going to go ahead and hit it. That would be 1,000 ohms, which is probably too high to see something very well. So what we're going to do is we're going to go down to ohms. That's 1. Notice the lines here immediately changed when I did that. Let's go ahead and just make it 300, just so you can see how the colors changed on that? And if I click on it again, I'll see how many ohms it is. Always a good idea to remember what that is. Now, I'm going to connect this up. So I'm going to take from the hot rail to the same rail as the resistor is. I'm going to go ahead and change that to red so I can track this. Then I'm going to go from here to the ground. All right. Now, it's probably, so I'll just take it from here so you can all see this. The red dot there. Change that. And there we go. Black. Now, let's look at what the circuit's going to go. Go from 3.3 volts, connect that rail to here, to the resistor of 330, to the long leg, the anode of the LED, that's the positive side, down to the negative, back to the ground. LEDs, it really matters. They're diodes. The direction of current matters. Other things, not so much. And then we can do something like this. I started the simulation and see it's a brighter red. If I stop the simulation, watch the LED. Watch, they plug it in here even now. It's gotten really spiffy. This USB is connected in. You got power. You've started the simulation. And what's great is we can do things where we can, if you increase that resistance or decrease the resistance, the LED would change. All right. I'm going to put everybody's hands down here for a second. We'll give everybody a chance to model this. So everybody go ahead and do it. Put your hands down. Raise your hand once you've got this. So again, you've dropped all these components in. Hit start simulation. See the little light come on? Yay! And end it. And you know it's on. With your USB's driven in there, your LED should come on. If it didn't work, troubleshoot where it is. Do you have both a ground and 3.3 volts? If you're going to 3.3, make sure these lines are connected. Make sure you're on the same leg with that resistor. Up to here is connected to the long leg of the LED. If you haven't rotated, hit R and move that around. It's got to be positive, go through that long leg, and then negative be the ground back. Okay, great. And again, I'll mention this once now, just so you know. In reality, actually, it goes in this direction. Current is actually flowing this way. But we decided a long time ago, the standard, we go in the positive direction. Which really, thinking about doesn't make a lot of sense. But here it is. We got a basic flow of that. Now, to get ready for what Mr. Toy Tom is going to talk to you about, is we're going to take this line instead of this. See, the problem with this simulation is the light goes on. Well, for the light to go on, I got to plug it in. Well, I want to program this. I want the computer to do it. So if I get the computer to do it, then I can tie it into sensors. And I can have the LED lights come on when it's dark. I can have the LED lights come on when the temperature's too high. I can have the LED lights come on when the engine's running too fast. Or, I'm going to make cool light targets and things, all right? So, that's annoying. Oh, Greg. Why else? That's what he loves. All right, there we go. Sorry about that, folks. All right, now, let me go on here. So, what we're going to do next, since we got everybody hooked up there, we're going to take this lead. I'm going to delete it. It's gone. And then I'm going to go to 13 over here. And I'm going to make it red again. Of course, now I'm on. All right, a minute. There we go. Pay attention to what you're doing there, Tom. There we go, red there. All right, so that's going from pin 13. Look at the LED now. It should flash. That Arduino comes with a code in there. It's called Blink. And Tom and you are going to work on that code so you can do this for real. I have built all kinds of robots. So has Tom. I build everything from $5 robots to several $1,000 robots, and I still enjoy seeing a blinking light. And some of the really cool stuff on Adafruit, all kinds of blinking lights. It's pretty sweet. So I don't think, has anybody got a question? We're going to hand this over to Mr. Toy, and he's going to start talking about how to program all this stuff. Tom, I don't think there is, so I think I need to hand it back over to you, don't I? Or can you do it? Let me see here.
I think I can take control back. Let's see here.
Yeah, why don't you do that?
Oh, yeah. Here we go.
I'll mute myself now for a while.
All right, everybody. Welcome back to my computer. So we went over how to set up the breadboard itself and the physical Arduino setup, which is it's going to be the same kind of setup. Now let's go over the actual software. Because the Blink program is built into 123D circuits, however, we are going to have to, there's an example of it, but we're going to go ahead and make it ourselves so we can take a look at some of the code and understand what exactly is going on. So with that in mind, show of hands real quick, who already has the Arduino software installed on their computer? Okay, yeah, pretty much the people I expected. Most people, but not quite everybody. So just in case you don't, it's real simple if you just do a Google search for Arduino. You've got Arduino software right underneath Arduino Home. Just go ahead and click on that. And once it loads, go ahead and install the Arduino software. Now, I imagine most of you are going to be running on Windows. The zip file is a safer option. However, if it's your computer and you know it's your computer, you can go ahead and use the installer. It's not really a big deal. The zip file is probably easier, though. Then, of course, if you have Mac OS X, you've only got one option. That's pretty easy. If you've got Linux, raise your hand.
Hey, Tom, you want to clarify again why you have a what do they mean by non-admin install for everybody?
Oh, okay, yeah. Well, basically, it's when with computers, you can set up different accounts that have different permissions. So you can say, okay, for this particular user, they're not going to be able to install anything on this computer without a special password, or this particular user is not going to be able to change the options in the control panel so that they don't mess around with the resolution or anything like that. An administrator on a computer can do anything. So that is to say, if this is your computer, if you own this computer and you use it and you've installed things on it, chances are you are the administrator. So you would be able to use the installer. If you're using like a shared family computer or something like that, it's possible, that you're not the administrator. So if you would try to install something, it would ask for an administrator password because you wouldn't have permission to install it. And that's simply all that means. So that's why the zip file might be a safer option, because in case you are not the administrator of your computer, in case you don't have permission to install things without a special password. You can get around that by just downloading the zip file and then opening it up from unzipping it and then opening it up.
Sometimes in school situations, obviously you have permission from your parents, you have permissions from the teacher, but this way you don't have to have the password to put it on there and work.
Exactly. Now I saw a couple of hands go up for Linux. I guess raise your hand if you have Linux and you don't already have it installed. Okay, good, excellent. So I don't have to go over 32 bits. Oh, wait, no, one hand. Okay. Well, just in case you're unclear, 32-bit versus 64-bit refers to basically the size of the words that the processor uses. Okay, you got it installed? Excellent. Handy. I don't have to go over that then. Sometimes explaining that can get a little tricky. Never mind then. Anyway, for those of you who don't really know, generally using the 32-bit option is safer if you're not sure which one you have, because 32-bit programs will work on 64-bit processors, but not vice versa. Okay, so I'm going to go ahead and open up Arduino and just spend some time going over a few different things while you guys are downloading it. Hopefully that should kill some time so that you guys can get it either downloaded and installed or opened or whatever in the meantime. Let me just go ahead and, of course, okay. I managed to move my browser window out of the way and get it opened. For some reason I'm being defeated by a browser window. Okay, so this is what the Arduino program looks like that you use in order to put software onto your Arduino. It's pretty simple. In fact, it's really simple. It shares some things in common with what are called IDEs, integrated development environments, that programmers use when they're making large programs. But that's just so your life is easier when you're working with it. It's not strictly a necessary thing. But just a real quick overview of some of the features here, and again, as we use them, I'll go over them again. I just want to show them to you guys. You've got this big area in the middle. That's where you enter in your code. Really simple. No surprises there. It's just basically a plain text editor, so you can't do like italics or bold or anything like that because it's not really going to be able to understand that. But it will handily automatically color it for you for different things, like variables will have a different color than keywords in the Arduino programming language. And that might make more sense in a little bit here. Down here is this little black strip here. That's a readout. That will tell you the status of your Arduino if you try to upload something to it. It'll tell you things went correctly, or maybe if something went wrong, it'll tell you what went wrong. So if your Arduino is acting up and not doing what you want it to do, usually this screen right here, this little info box, is your first stop for information on what might have happened. It might say, oh, hey, on line 13, I'm missing a semicolon. And you go, oh, okay, well, let me go ahead and put in a semicolon there and everything's good. Or it might say, hey, I can't find the Arduino and talk to it, in which case, you might have to spend a little bit of time wrestling with your computer in order to get it talking to the Arduino. Regardless, once we download and open the file, which folder do we open or click? It should be in your downloads folder by default. Is that what you mean? And if you've done it through Chrome too, there should have been a bar down here which popped up with the folder being downloaded, so you can always click on that, which saves you a little bit of time and effort to search for it. Once I click the Arduino file, a bunch of other files show up. Oh, okay. Did you download it as a zip file? Sounds like you might have downloaded it as a zip file. Okay, there should be one that's just called arduino.exe, or just Arduino, and it should have an icon which looks something like this. It's like a little infinity sign with a plus and minus inside of it, and that will be the one you want to open. If it's the zip file, though, you'll want to unzip everything first to a folder. So if you've got it open and it's like Windows 8 or something like that, there should be an option at along the top of the menu bar that says, here, let me just open up this one. It says Extract All. Thank you. Yeah, I was pretty excited for the new Star Wars movie coming out, and so I had to show that somehow. or that had come up. Yeah, you're going to want to click on Extract All and then select the location for it. As you can tell, usually I stick it on my desktop. But, if you have a folder or something like that, then you want to stick it there. And then open up the Arduino.exe. So, yeah, again, so this is the, no problem, information on what might have happened, what went wrong, and what went right. It's not always the most helpful thing. Sometimes it's a little bit obtuse in what it says. If that's the case, feel free to ask me. I'll help you out with that as best I can. I've got a fair amount of experience reading arcane and weird error messages, so we can probably figure it out together. Up here you've got a set of buttons, which are pretty handy. Verify just checks all the code to make sure that there aren't any errors. It's usually a safe one to click first. Upload will upload it straight to the Arduino. Now the thing is, it will also verify before uploading it. So usually you can skip the verify step and just click upload, and then it'll check everything and upload it to the Arduino. However, verify is a good thing to click as you're going through it periodically just to make sure everything's right. Then you've got new, pretty self-explanatory. Create a new file that you can start coding with. Open and save, also pretty self-explanatory. If you've ever used Word before, you've used that. If you've ever played a video game that has save files before, you've used those. Nothing new there. Serial monitor allows us to view information from the Arduino, basically have the computer communicate with the Arduino and send information back to the computer so we can look at it on a screen and see in real time what's going on. Now, it's not going to give us information unless we tell it to, so there is some extra code we might have to do in order to get the serial monitor to talk to the computer, or the serial connection to talk to the computer through the serial monitor. But we won't go over that today. We're just making a button blink. Up here, we've got a few more tools. A lot of the same stuff that we've been using, preferences, things like that. The ability to edit the text file, nothing crazy there. This is the verify/compile, which is the checkmark button over here. And then we can add more files or import a library. And a library is basically just a set of code that somebody else has done. So if you wanted the Arduino to communicate with an LED screen, because programming doesn't assume anything, we would do all the heavy lifting, like telling it what an LCD screen is and how to communicate with it and how to get information back from it and all that kind of stuff. Thankfully, there are people out there, very nice people, who have already done all of that hard work for us. So instead, we can say, display the word cat on the LCD screen. And because those people have done all the hard work already, the Arduino knows what an LCD screen is. It knows what you mean when you say print out cat. It does all that stuff, so it's kind of like a middleman, so that you don't have to do nearly as much work in order to get that kind of stuff done. And there are libraries for all sorts of things, motors and motor shields and joysticks and whatever, you name it, there's probably a library for it.
But do not worry for the contest that we're going to have you install, say, libraries. All right, guys,
okay.
Gals. We have that so you would see it, so you want to get something out of it, you can. Okay?
And there you go. Yeah, that makes it a little bit easier too. And then over here we've got tools. We're actually going to spend a little bit of time in tools here, just because there are a couple of options in here that you'll be pretty familiar with by the time you're done working with the Arduino. The first one is the board option over here. Now the board option, as you can see, lists a whole bunch of Arduino boards. And the point of it is different Arduino boards are going to have different commands. They're going to have different hardware installed on them. They're going to have, different protocols and things like that. So you want to make sure that you've selected the correct board in order for your computer to interface with it properly. Now, for you guys, I don't know why this is, there we go. For you guys, you're going to make sure that the Arduino Uno is selected, because that's what the SparkFun Red board is. It's an Arduino Uno in all but name and color. So make sure that one is selected. You can tell I've got a little dot next to it and a little blue square. That ensures that we're sending the proper commands to it and everything's communicating properly, and we're not asking it to do things it can't do and having it freak out and have a little fit at us. And then the next one is going to be serial port. Now, as you can see here, serial port is a little bit trickier because that one can be a little bit finicky. So I'll go over this process right now, but I'm sure we'll go over this process again in the future once you guys are, hooking up Arduinos and stuff like that. So don't worry about it if you don't remember the exact process right now. I'll just go over it. So those of you who do have an Arduino, you can maybe try it alongside and make sure that everything's working properly. Those of you who don't, maybe take note just so you're not completely blindsided when you do have an Arduino and try and hook it up. Now you'll notice under serial port, I only have COM1, which is short for communications port 1. This serial port thing lists all of the communications ports that are on your computer, and you select the one that the Arduino is hooked up to make sure that it's communicating. I know from experience that mine is not on COM1. However, that's the only one listed here. Now here's the thing though. Let me go ahead and plug the Arduino into the front of my computer. Just go ahead and do that right now. You might see some stuff pop up on my screen. You might hear a beep or something. Or my computer yell at me. So it gave me the verification that it was plugged in. If we go to serial port, you'll notice that I have COM1 and COM4 now. From experience, I know that COM4 is the correct one because that one showed up as a possibility once I plugged in the Arduino. Sometimes it won't always be so cut and dry for you guys. You might have to do a little experimentation to figure out which communication is the one that talks to the Arduino. Unfortunately, there isn't really a cut and dry set standard that I could say, oh, you guys, plug it, once you plug it in, select COM3, because that's going to be different for everybody's computer, even among the same operating systems. For you guys, it might be COM3. In the past, for me, it was COM3. So just generally, the easiest way to tell which communication port you want is to plug in your Arduino first. Check the serial port listing first, then plug in your Arduino, and then check it again, and the new one that's appeared will be yours.
That's a great trick.
Yeah, it doesn't work for everybody, unfortunately, but it's worked for most of the situations. There are always going to be some stubborn Arduino ports, or some stubborn communications ports out there, and some stubborn Arduinos. So you handle those as you come. But for the bulk of you guys, that's definitely going to be the easiest way to tell.
This is troubleshooting for you at school. You're using Arduino and you're trying to get it to work, and you can't get it at work. The problems on the Amazing Mechatronics are more of a direct nature of you're hooked up to Arduino and the components. One rule we have on the competition is we don't say the resistor isn't pushed all the way in. You can assume it's pushed in. You can assume if it's physically connected, it's completely connected. But this is so when you're at school or you've got a laptop and you're trying to program in school, you understand, hey, what to troubleshoot to get it working for you or your teachers.
Yeah, because despite the best preparedness and knowledge and things like that, there are going to be things which go a little wonky from time to time. So generally, it's a little helpful to know ahead of time what you might be able to do in order to stave off that wonkiness or fix it. So with that in mind, that's pretty much all of the features that I wanted to give a once-over on. Before we got started, hopefully everybody's got it downloaded now. I believe it's about 100 megabytes, so it doesn't take too long at all. Even on my internet, that's only about 5 minutes. Yes, it does take hardware or software. Okay. So what we're going to do is we're going to set up a program that causes the Arduino to blink the light on it. Now, I'll go ahead and do this as I'm typing. So the first thing I'm going to do is I'm going to set up the basic skeleton of all Arduino programs. These are two things that all Arduino programs are going to have. Of course, if it'll allow me to type, it's not going to allow me to type. I think it's oh, there it is. It just updated. Okay, it's having issues updating. So let me go ahead and restart it.
Yeah.
Hopefully. Perfect. Okay. So I'm just going to go ahead and type this in right now. Don't worry too much about typing it along with me because I want to spend some time talking about it. Now, these two things are in every single Arduino program. You've got two words, void setup on each of them and void loop on the other one. These are what are called methods or functions. They're simply chunks of code that repeat. That you can repeat by calling them, or they repeat on their own. Now, in the Arduino's case, one of these chunks repeats infinitely. Does anybody have any guess as to what that might be based on their names? Yeah, exactly. It's void loop. It's all in the name. Loop just means that it's going to run over and over and over again. Now, the way an Arduino works is it runs all of the code inside void setup first, and then it runs all of the code inside void loop over and over again for as long as it has power. Now, it might do some other stuff in addition to that, depending on how we program it. But at its core, at its base, an Arduino is always going to do these two things whenever you plug it in, and it has a program in it. It's going to go through its setup, and then it's going to go through its loop. And then it's going to keep going through its loop. And those things always need to be there. So we can get into what the void and the parentheses mean a little bit later, but for now, void setup and void loop are the two things you would need in there, as well as the curly brackets and the parentheses. Now we're going to put some stuff into our void setup because we want to set up some things for the Arduino when it first powers on. Usually void setup, you put maybe variables in, or you set up pins to get ready to take in information or send it out, whatever. Basically, you can think like, I'm trying to think of an analog here, when you're getting ready to study for a test or something like that. You can think of the setup as being the teacher telling you what chapters you want to study for and what information you need to learn for the test, whereas the loop is you actually going over those chapters and learning the stuff and reading through the book and that sort of thing. So in void setup, we're going to set up a pin to do some stuff later on. We're actually going to, well, let me do this first. We're going to do that with the pin mode command. Now you'll notice that pin is all lowercase and the M in mode is capitalized. That's because pin mode follows a naming convention that's used in a lot of programming. So get used to typing like that too, because if the Arduino doesn't know what you're talking about, chances are it's because you haven't necessarily followed this capitalization convention. But pin mode simply means set a pin to a certain mode. Based on what I just typed in there, what do you think it's going to do? Yeah, make the pin an output. Exactly. In this case, pin mode always takes two sort of pieces of information. In the programming world, they're called arguments. But they take two pieces of information. They ask, what pin are you talking about? And do you want to make it an input or an output pin? So we could say that, this was input, and we turn pin 13 into an input pin. But in this particular example, blank, we want it to be output. So we're saying pin 13 is going to be an output pin. We've established that with the Arduino. It goes, okay, cool, I know that now. I'm going to be sending power out of pin 13. I'm not going to be waiting for anything to come in from pin 13. And then I put a semicolon at the end because that's like the period at the end of the sentence. Most lines in programming, almost all lines in programming, are going to require that semicolon at the end. Again, like punctuation at the end of a sentence, it's just not proper grammar otherwise. So now that we've done the setup, we're going to do the loop real quick, and in fact pretty quick because we're about 10 minutes away from the end. So in loop, like I said before, the stuff we put in here is going to repeat until the Arduino loses power. So we've got sort of an interesting command here. It's called digital write. Now, digital write is simply, we talked yesterday about digital versus analog, where digital is just ones and zeros off and on a binary, if you'll excuse the pun, state, whereas analog can be anywhere from 0 to 100. It can be 56 or 94 or 33 or whatever. It can be a whole bunch of shades in between fully off and fully on. So in this case, we're saying digital write because we know that pin 13 is going to be a digital pin. The write simply means send something out. If this were an input pin, we would use digital read. But since it's an output pin, it's going to be digital write. And we're saying, and again, this takes two arguments, just like pin mode does, which pin it is, and an on or an off. The key word here is high, but it means the same thing as on. If we wanted to say off, we would use the word low. You'll notice also that it's all caps and it's blue. Once it turns blue, we know that it knows what we're talking about. So digital write 13 high. We're saying turn pin 13 on. Then we've got a second command called delay. Now delay, what do you think delay is going to do? I'll give you a hint. I'll put this in here. Exactly. Pause execution for 1 second.
Excellent.
Delay. Yeah, delay in milliseconds. That's exactly correct. So that's what this is the Arduino simply waits for a certain period of time, and it's in milliseconds, so thousandths of a second. So when we put 1,000 here, we're asking it for it to delay for exactly 1 second. And there's a little timer inside which counts everything in milliseconds, and then once 1 second hits, it moves on to the next command. In this case, it's another digital write. Because here's the thing, as I'm sure you guys have already learned, computers are smart, but they're also super dumb. They don't assume anything. So just because we know that we want the LED to blink, and we tell the Arduino to turn the LED on, and we call the program blink, the Arduino is not going to understand that the LED also has to turn off. We have to explicitly tell it to turn the LED off, because it's dumb. It can't extrapolate, it can't correlate, it can't do all the things that our fancy human brains can do and that we take for granted. We can say, oh, hey, I lit a match and threw it on that pile of wood. That must have been what caused the fire. A computer's going to go, oh, there was a match. I fell on some wood. Oh, hey, there's a fire now. And it's not going to be able to make a connection between those three things. And really, it's only going to be able to tell what a match is and what a fire is and all that stuff because we told it to. I'm really giving it a lot of credit for understanding what those things are too. It can do math really well, though. It can do math way better than we can do math. It's really good at that. So because we want the LED to stay off for a second as well, we're going to put in another delay command. So another delay 1000 command. So again, what we have here is we have a void setup which runs once, and we're saying pin 13 is going to send electricity out of it. It's not going to take electricity in. It's going to send electricity out of it. So pin 13 is going to be an output pin. And then we go into our loop, which is going to repeat forever and ever and ever. And it's going to turn the LED on. By that I mean it's going to send power out of pin 13 if it was hooked up to a breadboard with an LED on it that was taking power from pin 13. It would turn that LED on. Handily, the breadboards have an LED on them which represents pin 13, so you can just watch the light blink on that. Then it's going to delay for a second, then it's going to turn it off, and then it's going to delay for a second, and then it's going to go back to the top. I think you get the idea. So let's go ahead and verify the code real quick. And it's going to sit here and think about things for a minute. Sometimes compiling can take a while. As you can see, it says done compiling here, and then it says binary sketch size, blah, blah, blah. If that's all it says, you know you're good to go, because it's going to yell at you if something went wrong. You're not going to. It's going to be really hard to miss the fact that the program is unhappy with you for some reason. It's generally much quieter when everything goes correctly, though, which is the case with a lot of computer stuff, programming and Unix terminal and things like that. If it says nothing, you can generally assume that things are okay, which is a little bit weird to get used to. So we know that our code is compiled. Let's go. I'm going to go ahead and upload it to my Arduino because my Arduino is plugged into my computer. It's going to compile it again, and then it's going to say uploading, and it's going to say done uploading. If I look over at my Arduino, I know you guys can't see this. I can see that the pin, or the LED representing pin 13, is blinking on my Arduino. So I know that went okay, which is excellent. And hopefully, after going over this, you have an idea of what exactly the Arduino is doing at any given moment. Is there anything I should go over real quick on this? Anything in more detail that you guys might be unsure of, or something that I missed? I know it was more of an overview kind of a thing right now, and we'll spend some more time going into more of the details as we get to more complex programs. But yeah, for right now, that's a basic overview of the code using a really simple program. No questions. Excellent. Is there anything you think I should add, Mr. Dubik?
No, I think you're off to good start. And I think, folks, one good way to practice this is write the code and to make just slight changes and see how it reacts. So if you go back to 1, 2, 3D circuit, which we could pull up here, I don't know, if you'll give me the screen back.
Definitely. I was moving to do that right now, actually. All right, there you go.
Show my screen. All right, here we go. If I look down here, here he has pin 13. The / are comments, which we've. All right, so pin 13 has an LED, and what comments do is allow us to read it, make sure we understand it, and we're creating a variable called LED. A little bit instead of saying we're using pin 13 like we just did, and we signed it to a variable called LED. So the rest of the program, if we wanted to do a different pin, it's real easy. We just change it in this one place. Unlike math, we don't really like X and Y variables. We want to have variables that make sense. In this case, we're saying, hey, pin 13 is that variable. So you can see my LED's flashing there. Now, if I keep going down this, there's that void setup. There's pin mode. We could have said 13, but in this case, we have LED output, right? And then we have high and low. So one thing you can do on your program is let's try changing this, stop it. What we can do is it's upload and run. We can stop the simulation, go down here and say, okay, what happens if I make this 500? Well, what happens? Well, I would sit there and predict something and then start the simulation, see what it does, upload it, and run it. Now leave my light. Flashes just a little bit and is off much longer. I'd go back and change those things until you felt really comfortable, you understood what it did. All right, folks, hopefully that makes sense. Any questions? Remember, down there we can answer questions. Makes sense. Good, I'm glad. And honestly, when you're trying to learn different programming languages, Tom and I would tell you, it doesn't matter what languages you're learning when you're in high school. Just start using this logic. And if you're doing any kind of program, you're going to find you're using all kinds of different languages depending on what the client needs and what you're trying to do. And so you need, one of the tricks of learning new languages and getting up to speed real fast is to get a program that runs and start changing things and see what happens. And then slowly figure out what each line of code basically does. Is that,
exactly. Once you,
go ahead, Tom.
yeah, sorry. Once you know how to think in sort of a programming mindset, how to sort of do logical kind of steps in your head and see how all the cogs sort of work together. Once you have an idea of how the inner workings of a programming language work, at that point it just becomes learning the syntax of a new language. It's like people, who know Spanish have a much easier time learning Portuguese, or French or Italian, because it's a similar idea. There's the conjugation of the nouns, and there's the different kinds of verbs and things like that. It's Whereas people, who know English might have a harder time with those kinds of things because, they're not used to conjugating a noun to correlate with the gender and things like that. It simply becomes a matter of sort of learning the syntax at that case, in that case.
And in programming and engineering both share this idea. You take a complicated program, problem, challenge, break it into small pieces, solve each piece, and slowly build up. So if you were going to say, I want to make a light that goes off, a blinking light that goes off in my room when I open the door, or if I'm playing loud music, the start of that would be is simply get it to blink, and then get a sensor that checks, break the whole thing down in small pieces, and then work on it, and slowly build your way up. And you'll be amazed how something starts off simple, becomes more and more complicated, which is really kind of cool and added features. All right, how many people have got it working, made some changes, and gotten the simulation to work on 123D circuits? How many people have got it working right now? Okay, if you haven't, now's the time to do it while we're here. See, so that way you can show friends, you can have people work on it and get practice. The contest will be things like you'll go to a station, there'll be a display there, and we'll ask, hey, this light isn't lighting up at all. And you'll either look at the code to decide if the problem, or you'll see if the wires are hooked up wrong. So it's all about the kind of troubleshooting. All right. Okay, do we want to add anything today? We're going to stop it today and then get going pretty quickly again tomorrow, or Wednesday, Tom.
There's nothing really that I feel that needs to be added today necessarily.
I think we're at a very natural stopping point of using one LED. If you'd like, try to do two LEDs, because that's probably where we're going to be going next with this. How would you go about doing it? Remember, you always have to have void setup and void loop to do anything. Also, if you run a program with just void setup and void loop, it's a good way to clean out the memory, because nothing happens, but it cleans off everything. Okay? Well, if there's no questions, then it's now a little after 8. We know you're high school students. We know you've got a lot going on. And so we'll stop for tonight. Okay? I don't see any questions. Tom, do you want to add anything else?
Nothing here. I just hope it made sense.
Okay, we will put it up. We're going to load this one up by tomorrow morning. This webinar will be loaded up under YouTube under Young Engineers of Today, and the Science House will get a link on it sometime, I suppose. So just search Young Engineers of Today, and we'll put down Amazing Mechatronics 2016 will be the one to kind of search for. Look for Amazing Mechatronics, look for Young Engineers of Today. And we'll send, and the recording will be, that way you can also log in to go to webinar and look under recordings. You can find it that way as well. All right, everybody. If there's no questions, let me see. I'm looking over here. I'm just making sure there's none else. Oh, you're welcome, Brian. Thank you all for being a good audience. Take care. Bye-bye.
Have a good one, everyone.
All right.